Today we're going to go over using Revit with point clouds, and we're going to start by covering a little bit of background on managing point clouds locally on your machine, and then I'll hand it over to Mike, who will do a live demonstration in Revit. Okay, so a quick little background on PMC. Take a second here. So we've been around quite a while, done a lot of projects. I'd say we're one of the largest laser scanning service providers in America, as well as doing a full range of industrial engineering and CAD services. We do work around the world, including scanners located worldwide and some strategic partners that let us service and do jobs across the globe. Some of the things we specialize in, obviously, reality capture, industrial engineering, 3D CAD modeling services, and simulation and visualization services as well. So we're going to do some introduction to working with point clouds, and then working with point clouds in Revit, a live demonstration, and then wrap it up. So we'll start with some of the basics here. Okay, so let's get some terminology for those who maybe aren't familiar with laser scanning out of the way when we talk about different outputs and different types. So start with a scan. A scan is an individual run of the machine that we use to capture data. So any job involves doing multiple scans. Those scans are grouped together in a process known as registration, and they produce what's called a point cloud. So a point cloud, in theory, could exist of one scan, but it almost always consists of multiple scans, anywhere from a very small job, maybe 10 scans, up to 1,000 or 2,000 scans for larger jobs. So there's different outputs, and today we'll be focusing primarily on the outputs that go into CAD and in particular Revit. But you still have other outputs such as the point cloud itself and web viewers and things like that that allow you to see the point cloud. You have report data, which can be things like this heat map over here that shows elevation differences in a floor. And then it can be exported into a bunch of different formats depending on what you need to do with it. So a couple kind of questions we get a lot are when we supply data to people to work on, we give them all the data we created, and it involves all these different file formats. So I've listed some of the most common ones here, and start with the registration formats. And these are going to be the full point cloud data as it's stitched together in the registration software. In some cases, you can use this, actually with all cases, that all of these manufacturers offer free viewers that will let you open these file formats. Honestly, it's better to work with the web-based viewers for these. It's just easier. You don't have to install software on people's laptops, and these files are going to be huge in comparison to the export formats. So there's certain people that might need, let's say, an RCP, the people that are really using it heavily on a project. But for the most part, these are just files you want to archive somewhere so you have them for future reference. There's then a lot of different exchange formats, and these are how you get data from one program to another. You might see these on a hard drive that a vendor like us would give you. And these are sort of to be universal, the most common being E57, that lets you exchange the data between different programs and different applications. So these are the main working formats that you have. Today we'll be talking primarily about the RCS files. And these are the exports created out of Recap or another program similar to Recap that can create them. And these are a reduced point set that's optimized for use in CAD or BIM software. So in the case of RCS, it covers all Autodesk applications, pretty much across the board can import RCS files. You have pod files. Those cover anything Bentley or Siemens software. And then there's other things as well. There's a ton of different software out on the market now, including plugins. So there's Faro has plugins, Leica has plugins that will connect directly into Revit and allow you to reference those original data sets. And there's some benefit to those plugins, if you're a heavy point cloud user. So one thing we see people get caught up on, and I can't stress this enough, is keep point clouds on the local machine. Do not try to stream these across your network, right? These are completely unlike any other data you're likely working with. Where a very large Revit project might come in at 1 gigabyte, The average project we do in point clouds is 45 gigabytes, and we have many, many projects that exceed a terabyte. Okay, this is not something you want to drag across your network. It takes hours and hours to copy. So a little more about outputs when they go into CAD and BIM. You have support for pretty much every CAD application on the planet. And that started years ago now, and the support is pretty sophisticated at this point. And it even includes things like Navisworks can reference in RCPs, RCSs. There's even workflows that now will get point clouds, a limited data set into tools like Revit. Almost every tool on the market now has some sort of point cloud support built into it. So another thing to talk about here is point cloud and accuracy. And in general, what you're getting with a point cloud is something that's much more accurate than what we used to do, right? So we have countless examples where we've been called in to verify manual field checking that usually it's during the construction phase and things did not make sense. Manual field checking is simply not effective today. It never was, but it used to be the best that we had. So we get into the accuracy of the scans we take. This is a complicated discussion, but in general terms, the accuracy of a single scan is about plus minus 1 millimeter, assuming the scanner is has been calibrated recently and is in good working order. Then as we stitch the scans together, this is where accuracy gets a little softer. It can be as tight as I'd say 3 millimeter, but this can get quite a bit higher, both depending on the quality of the registration that was done. Bad registrations can be awful, but a good registration on a smaller project can hold, about 3 millimeter across the scope area. So another thing we run into, and we get questioned a lot when things don't meet what people expected a site to be, is the single scans are correct. So if we measured the distance between these two pipes in this picture, that distance would be extremely accurate. And anything that you've measured with a tape measure is not, if it doesn't match, it's not correct. What's in the scan is correct. There's essentially no way for the scans to come back completely incorrect. Now, when you get into the registration and you start stitching multiple scans together, you can have really, really large errors if that work wasn't done correctly and if audits and checks weren't done to make sure it was correct. So let's kind of dive in there. What do we do when we find things that don't make sense, right? That don't produce good CAD geometry? In this case, what do we do when the floor is not level or the walls are out of plumb? And this discussion varies on each project for us when we're the ones doing the CAD work on it. And it's always a discussion of really the quality of the CAD drawings you want versus how accurate do they need to be. So we've never done a building where walls were actually 90-degree corners, right? In real life, that simply doesn't exist. And walls are never straight, nothing's ever flat. So how do we want to reconcile that? So in this picture, the heat map, you're seeing almost a 10-inch deviation in the floor because the floor was collapsing in this building. And how do we want to reconcile that and create a usable CAD model? And these are discussions that you'll need to have. If you're doing the model, you need to have them internally. If you're outsourcing the model, you need to have someone have that discussion with the source that's providing you that model. Another common one is deflection. Okay. Again, nothing's ever straight, nothing's ever parallel, flat. We recently did a large factory project and we observed expansion joints that were fully expanded out. And so the center to center of columns at the base versus the center to center of the columns at the roof line was a difference of 4 inches. So you have to deal with this kind of reality that before we all sort of pretend it didn't exist. And this applies to any kind of steel structure. We will see the deflection in those steel beams. And how do you want to reconcile that? So there's no right answer to this. It really depends on the needs of your project and what you want to do. and what your outputs need to be. And with that, I'm actually going to turn this over to Mike to go through the live demo in Revit.
So back to Revit, what we're looking at now is a single-story office building. This is actually our headquarters in Dearborn. Over the past several weeks, we've been scanning interior, exterior, and roof, and pulling these RCS files together to create a Revit model of our office. Roof model was actually shot with a drone. We take aerial photographs and piece the photos together using a process called photogrammetry, and that allows us to create a point cloud with those drone photos. Now if we zoom in closely, we can see that there is a model under this point cloud. If I was to go to our visibility graphics override dialog box, turn off the model elements, what we're seeing now is a series of different RCS files. If I drag my mouse over this, we can see that there are 4 point clouds in here and a Revit link. So what I'm going to do now is hide the Revit link, and now we are just looking at the RCS files. Now if I go back to my visibility graphics override and I go over here to the point clouds tab, I can see the names and the visibility of 4 different RCS files. We pulled ceiling tiles in our office and did some scans above those ceiling tiles, and that can be seen when I isolate the above ceiling RCS. Now it's tough to see exactly what's going on from this view, but later on I'll show you how to slice through this point cloud and dive into what is going on inside there. Going back to the visibility graphics override, let me isolate our exterior. Now Chris mentioned using Autodesk Recap and exporting an RCS file from Recap. You can see these clean lines along the pavement, the roads, and the parking lot, as well as the roof parapet here. Now we knew that we were going to do a drone flight over this, so we did not need anything above that roof parapet that may have been captured in this exterior scan. So using Autodesk Recap, we're able to remove certain points and isolate the scope of the project. So we really didn't need anything beyond this box. And then RCS can be exported from Recap and brought into Revit, which is what I will get into now. Now, like most things in Revit, there are several ways to do anything. The most common way to insert a link or a family or a point cloud is to go up here at the top to the Insert tab. And you'll see that there are several options. For here, we're going to select the point cloud option. And right now it's going to bring me to the folder where all of my point clouds are stored. You may need to scroll through your machine and find the file location for a file you want to bring in. Types of files, because this is an Autodesk project, Recap, RCP files, and the CAD export, the RCS file, are our options. Because I don't have any Recap files in this folder, none are visible. So I will select an RCS file, and you'll see that the RCS files that I already have linked are select the file that you would want to import. Positioning, you have 3 different options. What we do at PMC is when we're aligning and registering our point clouds, we pick an origin point within that point cloud. It's usually some sort of hard surface like the corner of a wall where it meets a finished floor on the ground level. And depending on the scope of the project or what the client is asking for, we may pick that point and have it be 0 in the X direction, 0 in the Y direction, and either 0 or 100 feet in the Z direction. So that's kind of determined on a project-to-project basis. But once you have your RCS selected, you are going to click Open, pick your origin to origin. Since I've already got these loaded, I'm going to cancel out of that. Another way to bring in point clouds is to go up top to the Manage tab. And then over in the Manage Project location, you're going to select Manage Links. Now over here, you can see in the parentheses next to Manage Links, it says ML. That is a keyboard shortcut, and that is completely customizable based on the user. That's something that I've put in. So if we were to use the keyboard shortcut, we could simply type ML, and that will bring up the Manage Links dialog box. I'm going to go back here, select Manage Links, and here you see the tabs at the top are all the different link formats that can be brought into Revit. I have an MEP Revit file loaded right now, but if we go over to point clouds, we can see those 4 RCS files that I've talked about, as well as the saved path. Now all of these files are stored locally on my machine, which Chris mentioned in his presentation. It's just a lot easier. It saves on network traffic. If you have files stored on a server and you're sharing the model with people within your office, you always want to store point clouds locally. So I'm click OK. Now I'm going to go back to my visibility graphics, and I'm going to turn on all of these point clouds so we can see those again. Now, slicing through the point clouds and utilizing different views to see what's going on here, I'm going to pop over to a ground floor model. Now this is the first floor plan that we're looking at. As you can see, there are no point clouds visible. So by typing VG, we will be pulling up our visibility graphics override, going over here to the far right, clicking on this point clouds tab, and you'll see that none of the point clouds are visible in this view. So what we can do is check this box. You can see that the exterior and the interior RCS files will be visible once I hit OK. And there you have it. Now you can see the flooring come in here in this east wing and not being visible here. That's because there's a difference in elevation of the floors. You can see that here there's a ramp where the point cloud dips below the view range of this particular view. So I can show you how to alter that to view the point cloud differently. Now I'm going to go over here to Properties, scroll down to the View Range option and click Edit. Now you'll see that in this view, the cut plane is 5 feet above the ground floor level. So depending on your own preference, usually this is around 4 feet. We can see everything up to 25 feet above that first floor. I'm going to cut that down just to dial in on a certain slice of this point cloud. And the bottom and the view depth are set at 0. I'm going to bring that up to about 1 foot. So what we're going to be looking at once I hit OK is a 7-foot range of this floor. Now you'll see that cuts out the carpeting in this east wing, and now we're just seeing everything that occurs above the 1 foot view range and below the 8-foot view range. So this is good for quality check if we're in a model and we want to look at strictly walls and we don't want that carpeting or any other noise that may be captured. We can see here there's some casework and some countertops. See the matching on this water closet. Now if we're really stressing accuracy because that's the whole point of modeling off a point cloud, this is something I would bring up with my modeling team and say, hey, this desk is captured inaccurately. We want to edit this family, but this is a nice way to pare down the information so that you're really seeing the wall planes and able to model those accurately. Another thing I want to get into is cutting sections. You'll see I'll already have one created here. It goes along a grid line. And the reason that is because we want to take a look at how some of the trusses are being modeled based on what was captured when we scanned above the ceiling tiles. And you'll see here that here up top you can see the metal decking. You can see the truss above the ceiling, some of the HVAC, ductwork, some wiring. But you'll see that this is just a small slice of a section that is being viewed. If I go back to my ground floor, you can see this dotted line box shows the extent of that view range on my section. Another thing I want to get into with point clouds is how they're perceived, some of the visibility settings in Revit. And these can be changed going back to our visibility graphics override. If we go over here to the point clouds tab, which we've navigated through before, there's a color mode here. And there are several different ways to alter how the point cloud would look. And this is entirely based on, what the user prefers. For me, I've always been used to the RGB. Some people may want a single color, whether that be red, they can pick their own. For now, we have red as a default. So you can see that exterior RCS becomes red. So this could be useful if you want to highlight a specific RCS. Maybe this appeals to the specific Revit user. So that's something that you might want to do with all of your point clouds, or if you're just isolating specific elements. Another way to slice through point clouds is if we go into a 3D model, we can turn this section box on, and once we grab that section box, you'll see these blue arrows. You can start slicing that plane. We're getting to the front of the building now. And now we're looking into the building. Maybe we want to grab this back side and really narrow down the window that we're looking at and getting a nice slice of the point cloud. Square that up using our navigation cube up here. And we are looking through several different RCS files here. Now going back, some good practices when bringing in a point cloud. You always want to check at the bottom and see what the active work set is for that point cloud. I recommend always creating a separate work set when you're in a collaborative Revit model, because it's easier to separate and turn off or change the editability of a point cloud when you're inserting it. Another good practice is to always pin a point cloud in place. Now you can do that by clicking on the point cloud. We'll see in the properties tab that this exterior RCS is the one that we have selected. We go up here and we can see that this thumbtack is grayed out. So this object is pinned. There is no way for me to accidentally slide that in any direction. And that is critically important when we're bringing in point clouds. We don't want any user that may be in this model to accidentally shift a point cloud even, a couple of millimeters or a quarter of an inch, because that would throw off any modeling that's done after that point. So just to make sure that all of these point clouds are pinned, I'm going to drag across, go to my filter tool. I'll see that I have 4 point clouds selected. But now we go up here and we see that this pin is not grayed out. So there is a point cloud in here that isn't pinned. So I select that now and we see this pin here. So now all of these are locked in place and cannot be shifted. So that is bringing in a point cloud, is making sure that it stays in place, stays on its origin point, and is not accidentally moved by having multiple users in this. Now, I've mentioned origin point before. We brought all of these models in using origin to origin, meaning that the origin point that we established in the point cloud software, whether it be Recap or Faro Scene, we determined that that origin point would be 0, 0, and then the Z direction would be 100 feet elevation. And we also established that in Revit. We go in here, we can see that the interior corner of this wall was our origin point in Revit. When we brought the point cloud in, it lined up and we began modeling from there. To summarize all of this, the visibility of the point cloud is entirely based on user preference, how you slide through a point cloud, whether you go into a 3D view and use the section box, whether you go to a floor plan, cut a section, and then gradually move that section to see varying slices of the point cloud data. I've shown you several ways to view the point cloud data, figure out what you like, how you want to utilize the data once you have it in Revit, and you can begin modeling from there.